Okay. So I need to click on that orange arrow, right?
Yes.
Okay, thanks. So very good afternoon to all the participants here today for the webinar on the effectiveness of virtual labs in engineering education. What do we measure? I'm Anita Divakar from IIT Bombay, and I'm presenting this on behalf of my guide, Professor Santosh Narona, also from IIT Bombay. Now, this is the outline of my presentation. Now, the basic motivation for this work came with 5 years of study in engineering education. I have been in this field for the last 25 years, and lot of discussions happen about the quality of engineering education in our country. And in 2010, World Bank, Andrea Bloom and Hiroshi Saiki, they proposed this report, and they pointed out that the skill gap, especially in Indian engineering students, are particularly severe in higher order thinking skills. The graduates lack higher order thinking skills such as analyzing, evaluating, creating, problem solving, conducting experiments, and data analysis. And immediately next year in 2011, NASSCOM came with a survey report, again stating that the engineering students in India lack in skills such as relating theory to practice, experimentation, data analysis, critical thinking, debugging. Now, if we see carefully, most of these skills that we are mentioning here, they are related to the laboratory work that the students carry out in engineering. I strongly believe that engineering happens in laboratories, and with a effective implementation of classroom plus laboratories, naturally these skills can be enhanced in the engineering students. Now, even the government of India have been working in this quality of engineering education in our country, and there have been a lot of reports. Even IIT Bombay, Professor Angan Banerjee has come up with a comprehensive report on the engineering education in India. And in that it was found that most of the institutes in our country, they lack in resources which are required for the setting up of laboratories. Laboratories are hardware intensive, lot of costs are involved there, and especially in courses in the third and final year of engineering, the laboratories, they need lot of state-of-art equipment. Not only that, as the technology is advancing, naturally the universities are changing their curriculum to keep them at par with the technology advancements. And what is happening is that new electives are being introduced to the students. So it is very difficult for the institutes to come up with laboratories immediately having all these state-of-art equipment. And when government found this gap that was existing in the infrastructure, if you compare the infrastructure of IIT Institute, Indian Institute of Technologies, or even the National Institutes of Technology and the private engineering colleges, the self-finance institutes, I'm not saying that all self-finance, they lack these resources, but many are there, especially in rural, remote areas where there is a lack of resource. And managements and the faculties, they are trying hard to bridge the gap, but it is difficult. So with this problem in mind, the Virtual Labs project was launched in 2009 by the Ministry of Human Resource Development, MHRD. This is an initiative of MHRD, and the slide that you are currently seeing is basically on the left hand side. You can see the map of India, wherein the Virtual Labs project is covering major portions or all the states of our country. And the labs are developed, the right hand side, the extreme right, shows the number of labs which are developed for each of the domains in engineering. As you can see, the maximum virtual labs have been developed in biomedical and biotechnology and computer science. And then next comes the electronics and communication and so on. Now, under IIT Bombay, we have developed again virtual labs in most of these domains. We have contributed to the project. And not only that, now the virtual labs have been developed, they have been implemented, they are available online for the students. And now we are in a what is called as an outreach mode, wherein we are setting up nodal centers, conducting workshops for the faculty and the students. So we have conducted more than 100 workshops, more than 250 colleges are now nodal centers, trained more than 5,000 faculty members, and more than 2 lakh students have been trained on this particular online labs, that is a virtual labs. I am very happy to share this information with you that India is the only country in the world where these virtual labs are available to the students online free of cost. And the virtual labs, they are available at these URLs, www.vlabs.ac.in. And the next slide, you can see that is the portal of the vlabs.ac.in. So the online labs are experiments. So you can see there are 205 labs, more than 1500 experiments, and so many visitors and so much of usage is there. And there are labs in each and every domain of engineering. So now coming to the, so naturally these virtual labs are the new technology which has come into picture, and we are trying to explore this new technology for the purpose of education. So when we use this new technology in education, we call it as a technology enhanced learning, or TEL. That is a jargon which is used in education. Technology enhanced learning, whenever we use a new technology for learning purpose. Now any new technology, when it is used in education, there are 4 metrics over which we try to assess these new technologies. So the 4 metrics are attractiveness, accessibility, efficiency, and effectiveness. See, after studying literature on virtual labs, it was found that most of the literature is targeting these 3 metrics of attractiveness, accessibility, and efficiency. Because unless these 3 are met, the 4th one, that is effectiveness, cannot come. So what do you mean by attractiveness of a technology? Basically, it means whether the students and the faculty members or a user of that technology find it attractive enough. So how do you measure this when it comes to students? We measure it using their motivation levels. So whether students are more motivated to working in the virtual labs, or they are less motivated, and what are their perceptions about these new technology labs. So this is how we measure the attractiveness of the virtual labs. Then accessibility. Naturally, any technology, unless it is accessible to a larger population, it is not going to be adopted, and naturally it is going to hinder the overall usage of that technology. So under accessibility comes scaling, whether we are able to scale this technology to larger number of users can be increased. Then what is the language which is used for conveying the information or the knowledge. Then whether these new technology labs, they can cater to the different learning styles of the students, and they can they can cater to a large number of population, and of course the availability of the labs. So as I have mentioned earlier, these labs are available online 24/7 over the internet, and they can be accessed anywhere, anytime. So that is a very important factor which comes into picture here with the virtual labs. Then next is the efficiency metric. So efficiency, naturally, as I have mentioned here, that the cost of equipment and infrastructures for the laboratories are very high. So naturally these virtual labs are a preferred mode, because they are going to reduce the cost of the equipment, because the equipment is a virtual, which is available as images on the screen of the laptop or desktop, whatever the student is working on. Naturally, the infrastructure cost is reduced because we are not going to have high-end equipment which is required. Then demand on space. This is another metric which is used for the efficiency. Then the safety measures. See, in most of the labs, it is very important that the students, they observe the safety measures. Here, the safety measures, of course, there are safety measures which are incorporated, but as a online, like warning, in the form of warnings or dialog boxes which the students get if they do not follow certain safety measures. And then naturally, the instruction, the time of the instructor. So these labs are basically for self-learning. In the most of the labs are in the self-learning mode. So students need to work in these labs on their own, one lab, one student. So it's like, self-learning. So naturally the instructor time is getting reduced because of this. So all these three metrics, they are fulfilled. And what we are currently working on is the effectiveness metric of the TEL. Now, when we say effectiveness of virtual lab, there have been a lot of debate, lot of literature says different things about what do you mean by the lab is effective. Now, after going through literature, we found that effectiveness can be measured, or there can be two measures for the effectiveness. So, effectiveness one is basically the extent to which the students' actions match those that the teacher intended. So the lab work is allotted to the students based on what the faculty or the teacher he intends the students to do when they go into the lab. So first effectiveness is whether what the teacher intends that the student should do in the lab is exactly matching with what students actually do in the lab. So that is the first effectiveness, effectiveness 1. Then the second effectiveness or effectiveness 2 is extent to which the students' learning matches the learning objectives the teachers have set. So whenever the teachers, again, or the faculty members, they give this laboratory work to the engineering students, they come up with certain learning outcomes. For a particular course and a particular topic, the teacher has in mind that, okay, if the student is doing this lab work for this particular topic, then these are all the objectives that they should meet. So these are the teacher's goals or the objectives for that particular experiment. So the effectiveness 2 is basically what? These are the objectives set by the teacher, and these are the objectives which are met by the students, or after performing that experiment, the students have these learning outcomes. So if the two are perfectly matching, then we can say that yes, effectiveness 2 has been met. Okay, so these are the two effectiveness metrics when we talk about the laboratory work. So we will be now onwards discussing more on this particular metric of effectiveness. Then again, when we say the knowledge domains, in any field for that matter, there are three domains: cognitive, affective, and the psychomotor. So laboratory work basically has to deal with all the three, but we are focusing more on the cognitive domain. So our work is focusing more on the cognitive, and then later maybe we can go to affective and psychomotor if we are complete with the cognitive domain. So the first research question that we try to answer through our study is, what are the perceptions of engineering students and faculty members regarding the parameters contributing to the effectiveness of virtual labs? Like, what do the engineering students and faculties feel that, okay, the virtual lab is effective because I feel this has happened, and so on. So for that, we carried out a survey. So in that, 113 undergraduate engineering students and 37 faculty members from different colleges under Mumbai University, they participated in this study. Then we conducted workshops for diploma and degree level engineering faculty. In the workshop, we gave a 30-minute presentation to the participants describing what are virtual labs and so on. giving a demo of one of the labs. Then the students and the faculty members, they were made to work with the virtual labs in their domain for about an hour. And then a survey questionnaire was administered. So the effectiveness metric parameters that, see, as per the literature analysis, these were the 5 parameters that we came across after doing a comprehensive literature survey on papers related to virtual labs. So the first metric they say is the suitability of virtual lab in learning concepts. That is, whatever concepts they study in the classroom, they should be able to, their understanding of that concept should be enhanced using the virtual lab. Then second, the students' preparation of tasks in the physical labs. So in many outside universities, what they are doing is the students work with the virtual lab, and once they are confident enough on that particular topic, then they go to the physical lab. For example, in one of the papers on virtual labs, what they have done is for this chemical engineering virtual lab. So initially they were given a demo on what are the virtual labs, or they were given a video showing the different, in chemical laboratories, it is very important that the students find out what is the function of each of the utensil or the glass equipment that they are using. So many students in chemical engineering, they are a bit apprehensive of this usage. So they have used these virtual labs in order to prepare the students for the physical tasks. Then the third parameter was understand theory behind the experiment. Then emphasis on teamwork and support pre-lab training. So the third is that they should be able to understand what exactly is the theory behind the experiments. So for that, people have used the virtual labs. Then foster self-regulated learning. That means students should be able to learn on their own. And then achievement of students' learning outcomes. So all these 5 were the parameters which we came across in the literature, and the columns, 2 columns that you see, they are the percentage of faculty and students who agreed that yes, this is an important parameter for the effectiveness. Then we came across the parameters as per the survey questionnaire. So we had given them a survey questionnaire. So these 8 came out after the survey. So 70%, 85% of students, they feel that features of virtual labs are very important. Like, what is the virtual lab affording me to do? What all I can do using this? So features are very important. Then the tasks the students perform while working with. What exactly the students are doing when they work with the virtual lab? Is it that they are just observing a video? They are just looking at animation, or it is something else? So that matters a lot. Then third is the process through which the students go through while working with these labs. Like what exactly the students are doing. Then the learning of students using virtual labs over a period of time, that is over 1 semester, how much they have learned using the virtual lab. And 100% of the students, as was expected, they feel that the assessment of the task, because this is a very important thing nowadays, students, the assessment has become a very important factor, and students are more worried about how much marks I'm getting in the lab work. And of course they need to, because many other things are dependent on their marks that they get, the GPA that they get, and so on. So they feel that the assessment is a very important factor. The duration of time that the students spend with virtual lab. Now in the physical lab, the students, they can work only for the 2 hours or 3 hours slot they are given for that particular experiment, for that particular course. Whereas virtual labs, they are available throughout the day, 24/7. So that is very, very important parameter. Then alignment of tasks with the learning outcome. This is a parameter important from the teacher's perspective. Whether whatever the teacher is expecting outcome of that lab should be the task that the students perform should be aligned to that. And then the feedback provided to the students while performing the task. So that is also very important. Normally in the physical labs, it is the lab instructor or the faculty members who are present in the lab while they are performing the experiment. And if they are stuck somewhere, they are given a feedback. Whereas here in virtual lab, it is a self-learning mode. So naturally, does it mean that there should not be any feedback? Of course, whenever they are doing a virtual lab experiment, they are going to get stuck somewhere. So this feedback is very important for the students as well as the faculty perspective. So once we are aware of what are the parameters which can contribute to the effectiveness, the other questions that we tried to answer was, how does the learning with virtual labs change over time? And what are the features and the tasks which contribute to the effectiveness of virtual labs? So for this particular questions, we carried out a longitudinal study. Now, what do you mean by longitudinal study? Longitudinal study is a study wherein we have the same intervention over a period of time, multiple times. So the students, they performed 6 experiments over a period of 1 semester using virtual labs, and then we assess their performance. Now, before carrying out the study, the most important thing that we looked at were the learning objectives. See, again, coming from the literature, it was found that till the year 2002, see, in the during the era of World War One as well as World War Two, engineering was mostly related to what happened in the laboratories. So more and more weightage or focus was on lab work. But slowly, as the focus shifted from this laboratories, it started shifting towards research and towards classroom activities more. And then there was a period wherein people were not very sure about what exactly we want to achieve when the students are working in the labs. So in 2002, a colloquy was held. So many experts from engineering, they identified with what are called as the ABET criteria. So I hope all of you are aware of what is ABET body. So they came up with these 13 criteria that should be fulfilled in the engineering education laboratories. So these 13 criteria are instrumentation, models, experiment, data analysis, design, learn from failure, creativity, psychomotor, safety, communication, teamwork, ethics in the lab, and sensory awareness. So when we say engineering education laboratories, as per ABET, these 13 criteria should be met, not in a single lab, but when the students are working in this 4-year course, in say maybe around in each year, maybe they are working with say 10 labs. So in these 40 labs together, these 13 criteria should be met. Now out of these 13, we have selected 6 which are in the bold letters. So these 6 criteria are the ones which we have selected for the purpose of our study. And this is a theoretical framework which we use for teaching with virtual labs. So now, as you can see, the first component of this is the features of virtual labs. So what exactly this virtual lab, what are the affordances of this virtual lab, or what are the different things that the students can do in this? Then tasks in virtual labs. Now what are the tasks? Giving the example of an electronics lab. So what is a feature that the virtual lab is providing me? That in my virtual lab, there are different components like transistor, diode, and so on. And what is the task that the student can do? The student can use these components. That is, there is a workspace available and the student can drag and drop the components. So that is a task that the student do. Now along with these two, what we are doing is we are giving them a scaffolding in the form of online material. So what is this online material? This online material is basically related to the task. So once a student performs a particular task, there will be a question in this material. So they perform the task, they answer the question, perform the task and answer the question. And these tasks are naturally aligned to the learning objectives. So these 5 learning objectives, that is instrumentation, data analysis, experiment, models, design, and learn from failure. So the tasks are aligned to the learning objectives. So when the students perform these tasks, these learning objectives are going to be met. And Along with this, what is going to happen is they are going to develop some higher order thinking skills. So these tasks, the questions on the task and the learning objectives together can lead to the development of these higher order skills. Now the educational technology theory that we are using for this is the BICS constructive alignment. Constructive alignment means the task, the learning objective and the assessment, these two should be aligned to each other. Now normally in the traditional labs, in the physical labs that we see in engineering, what is happening is we are assessing the students only after they have performed the complete experiment. So what we are assessing is basically the end product of that lab. So what we propose here through this study is that instead of assessing the students only at the end of the lab work or only at the semester as a practical exam or a practical oral, it is found that students are finding this is not a very fair method of assessment, and even the researchers, they are saying that this is not fair on part of the students as well as the faculty members, that we are assessing only the end product and not the process through which the students go when they are working with the labs. Because in the classroom it is fine that we are assessing their end product because we want them to learn certain concepts, but here it is not just only the concept but also the procedure. So when they are doing the lab work, we need to assess the process. So we have come up with this virtual lab learning process measurement technique. So what we did was we selected a particular course. Then for that particular course, we selected the virtual lab which was suitable for the course. Then we identified what are the features that this virtual lab is having. Then selection of the suitable ABET criteria. Based on what are the features, we selected the suitable criteria which can be fulfilled using this. Then mapping of the ABET criteria with the learning objectives, because we have to go to the granularity. It should not happen that we take something broader and then we come up with some questions which are again broad and we are not going into the depth of the matter. So then once we have mapped the
Hello.
hello.
Yes, ma'am. We had
Hello.
lost your audio for like few seconds.
Actually, there was, yeah. Actually, there was a problem here. The lights have gone, so I have put on a backup.
Okay.
So can I start again?
Yes, yes,
Okay,
yes.
thank you. Okay, so this is how we come up with the learning process measurement technique. And then for the electronics engineering laboratory, these were the learning objectives which were selected, that is selecting components and equipment, constructing the circuit, operating equipment, collecting data, analyzing the data, concluding from the results, then identifying bugs in the circuit and rectifying bugs. In any electronic engineering laboratory, if you see, these are the main objectives that the students, or these are the main activities that the students basically do. So here again we have used what is called as a Kolb's experiential learning cycle. So this has been, this is an established theory, educational technology theory, that if the students are taken through this particular cycle, then the learning is as per the need, or as per the objectives can be met. So the first is a concrete experience, then reflective observation, abstract conceptualization, and active experimentation. So we also carried out this as per the next slide you can see. So in the first experiment, the VI characteristics of diode, normally what happens, so we divided the class into two groups, control group and experimental group. So control group student, they do normally whatever is done, like for it's a 2-hour session, so naturally for 1 hour they perform the experiment, and then the next hour they do what is called as a reflective observation. Whereas the experimental group, what they did was, there was a concrete experience, and so this 60 minutes that they go through in the lab, that is they perform one experiment, that is VI characteristics. Here again we have divided into concrete experience and reflective observation. There is a cycle of this, as you can see. Then there is a abstract conceptualization, and then again a reflective observation. So what happens because of this is that the students are performing a particular task, reflecting on that task. Like for example, they observe the waveform of the characteristics of the diode, and then immediately some questions on that are asked, like what is the nature, do you see the piecewise linear characteristics, where is the non-linear region, and so on. So this way what is happening is that is getting reinforced, the concepts are getting reinforced in the students' minds. Now, after this, what we did was we compared. So while they are performing the experiment, when they are reflecting on this, these reflective observations are basically the questions. So they are answering to these questions. So while they are performing the experiment itself, their assessment is getting done. And that test, we call it as the learning outcome test. So we are not taking a test only at the end of the lab, but while they are performing the lab. And these are the different objectives for which the questions are set for all the 6 experiments throughout one semester. So the results, these are the results for one of the students that I'm showing here. So as you can see, as the students approaches from task 1 to task 7, and then this as you can see, there is a color code for experiment 1, 2, and so on. So the weightage that the student, the marks that the score that the students are getting, it is increased. The next slide it will be more, we'll be able to gauge it better. As you can see, the blue dots are for the control group students and the red are for the experimental group students. So the average marks, if you can see, for all the 3 experiments, we can see it is around 12.5, whereas for the control group it is around 7.2. So we found a drastic difference between the marks in the students, or they were able to perform better than the control group, the experimental group students. And these are the results after the statistical analysis using the SPSS software. So as you can see, for all the this learning objectives, the mean is much higher for the experimental group than the control group, and the effect size is also large. It is more than 0.5. So effect size of greater than 0.5 is considered a large effect size, even though Cohen's d is large. So we can conclude with this that the experimental group students have done very well compared to the control group. Not only that, we have measured not just their outcomes, final outcomes or the final product, but the process through which they go through while they are performing the experiments. So what is the benefit of this? Benefits from students is that they have a fair assessment. So they are being assessed for what they are doing in the lab. And then we are measuring the learning gain and not just the end product. And what is the benefit from instructor perspective? They can give different tasks to different students, thus avoiding plagiarism. Yes, of course, this is one of the greatest disadvantage that we are seeing in current system, that what happens is one of the student or maybe 2 or 3 students in a batch of say 20-25, they write the answers and the others are just taking the answers from them and copying. So that can be avoided because this is an online test and they are writing the answers when they are performing, and each group can have a different answer and a different task. And then of course we can have a semi-automatic. This can be made semi-automatic so that the instructor load can be reduced. We are working on this automation. Some of the tasks can be automatically assessed while they are writing the answer. So we are working on this semi so that the instructor load can be reduced. So this is all about this effectiveness of virtual labs, how we have measured, and what are the different ways in which the lab work can be made more and more effective, and benefits can be had for the students as well as the faculty members. So that's all. I think already 1 hour is over, and thank you so much, and sorry for the interruption that happened in between. Thank you. Hello?
Yes, ma'am.
Yeah, so my presentation is over.
There are some
If there are any
things.
questions.
In outcomes-based
Okay.
education, ability development is very important. The lab work is required to essentially develop the affective and psychomotor domain ability and not cognitive
Yes.
domain ability. For development cognitive domain ability, there are numerous methods, maybe better than virtual lab. Your comments, please.
Yes. See, basically, there are no labs which are dealing with psychomotor and teamwork skills, basically. But my study, my research focus is in the cognitive domain. But I will not say that. See, there are labs developed by Amrita University where they are taking into this haptics part also into consideration, where no students are. Then there are virtual reality labs wherein the students are, they get a feeling of realism, like as if they are working in the real lab. So yes, definitely these are important skills, and there are technologies available online which can be used for developing these skills as well. But my focus is in the cognitive domain.
In real lab, students get an opportunity for hands-on, struggle, mistake, explore, experience, observe, take immediate feedback, produce product, prepare report, and the like. How are these addressed in the virtual lab?
Yeah, see, in the virtual lab, again, I have mentioned only one type of lab, that is simulation labs. But in virtual lab, there are other very important type of lab, which is a remote triggered lab. So in the remote triggered lab, what happens is the physical lab is located, say for example, in IIT Bombay, one of the labs in IIT Bombay, and students sitting at home, they can actually see what is happening there through the web camera. Okay, so for example, we have this single board heater system which is hosted in our campus. So there, this control design. So students, they design their control algorithms on a simulation. They test also on the simulation, and once they are satisfied that okay, the control design that they have done, either P or PI or PID, is satisfactory, then they can download their logic into the actual hardware and actually see what is happening. And again, another thing, like, yes, I totally agree with what what you are saying, that yes, hands-on is very important when it comes to lab education. So we are not claiming that virtual labs is a substitute for physical labs. That's why I started with how to develop higher order skills. So what my research is on, basically how these labs can be used to develop these higher order thinking. See, in physical labs, yes, they are learning hands-on, they are getting the immediate feedback, they are getting what are the errors and so on. But what is happening is, while performing the experiments in the labs, they are only dealing with objects. When we say lab education, basically there are two things that should be taken care of: the objects that the students handle and what are the ideas behind the objects. For example, in case of electronics engineering, we say that okay, you are connecting a voltmeter in your circuit, right? So when we ask them a question in the virtual lab, okay, what is the purpose of the voltmeter? So what is happening here? They are having this link between the object and the idea. So what is the object? Object is a voltmeter, and what is the idea behind that object is that it is used to measure the voltage or the variable that is called as a voltage. So this link is very important, and that is not happening in current labs. Unless they make a link between the object and the idea that is behind that object, we are not able to fulfill the total objectives of the labs, engineering labs. So I am not saying it is a substitute for the hands-on. Yes, of course, for many of the skills, they need to have this. That's why what we are proposing is that out of the 10 experiments that the students perform in a course, they can do 3 experiments using these virtual labs, wherein these labs are giving them an opportunity to make these links between the objects and the ideas, and they are having a fair assessment. That's it. Any other question?
I think 1 minute. Who will be there for us to assess or mentor in virtual lab?
Okay, see, most of the virtual labs, they are available online, and